Welcome to Mr. V Teaching Math. In this session, we're going to look at comparing fractions. This time, we'll talk about cake instead of pie. You've got to imagine Jimmy and Joey. Jimmy and Joey like to compete in all kinds of things, and they happen to meet, and they're talking about how much cake they ate for dessert the last night. And Jimmy says, "Oh, I ate 2 pieces." And Joey says, "Ha ha, I ate more than you. I ate 3 pieces." But how big were the pieces? These 2 pieces are bigger than those 3 pieces. When you're talking about fractions, you cannot compare them unless the size of the pieces are the same, or the denominator. These are not comparable unless you make them the same, which you can do. So let's take a look at comparing. First of all, we'll start with the one in which the denominators are the same. This is fairly easy to compare. Because the denominators are the same, you know the pieces are eighths. This one has 3 pieces of 8, and this has 5 pieces of 8. Which one has more? Well, we often use this symbol. And by the way, some people often forget which way am I supposed to go. And in order to remember that, this is what I do. I turn it into a hungry alligator, and he always eats the bigger one. So, this one's bigger, there are more. What about this kind of question? The denominator is not the same. However, we can create equivalent fractions and find an equivalent fraction that has the same denominator. In this case, I know that I can simply turn this into an eighth by timesing it by 2. So I end up with 2 eighths. And now I can see immediately that this one is bigger. What if I have to compare 3? And let's say that I am supposed to put this in order from the least to the greatest. First of all, I have to create a common denominator for all of these. The lowest one that I can find. Trust me, you want lower ones. I mean, I could simply take 10 times 9 times 2, multiply those 3 together, and I could end up with a really big number that they would all turn into. But it's going to be really big. And this is where we learned about the lowest common multiple. I want to find the lowest common multiple for these 3 numbers. And divisibility rules are going to help me in that. So I can think about all the multiples of 10, 10, 20, 30, 40, 50, 60, 70. What's the first one of those that 9's going to fit into? Well, it's going to be 90. Now think about the 90. Is 90 also divisible by 2? Well, yes it is, because I know my divisibility rules. So I'm going to convert all of these into something over 90. What do I have to times this by to turn it? I have to times it by 9. 3 times 9 is 27. To turn this into 90, I have to times it by 10. 2 times 10 is 20. To turn this into 90, I have to times it by 45. And now, if I want to put it in order from least to greatest, I can then take, and I can see that it should be 2 over 9. Sorry, not this one. 3 over 10. And then, last one, 1/2. From the least, because it's 20 over 90. This one in the middle, 27 over 90, and that one at the end. Let me do another example of something similar. Lowest common multiple of 2, 4, and 3. Well, let me start with 2 and 4. Well, 4 is actually a multiple of 2. So, if I were to just do those 2, I would turn that into a 4. However, I have to get 3 in there as well. So if I think about 4 and 3, I go to 8. 3 won't go into 8. Then I'll have 12. 3 goes into 12. So I'm going to turn all of these into 12. Something over 12. Times this by 6. That's 6 over 12. Times this by 3. That's 3 over 12. Times that by 4. That's 4 over 12. And once again, if I want to put those, okay, from least to the greatest. That means this one is the least, so it's 1/4. That one's in the middle, 1/3. And that one is the greatest, 1/2. And that is how to compare fractions.